Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about Vector, another implementation class of the list interface. So by the end of this video, you will understand what Vector is, its features, how it works internally, why it is thread safe, and when you should use it. Okay, so let's get started. So what is Vector? Vector is a class that implements the list interface. So as we know, the hierarchy, okay, iterable, and then collection interface has list, set, and queue. So this all are interface, iterable, collection, list, set, queue, all are interface. Now list has the implementation class ArrayList and linked list and vector. So we are learning about vector. So vector is what? Vector is the implementation class of the list interface. Okay. So whatever properties we have read for the list interface, the same properties will come for the implementation class since it is implementing that interface. Okay. So vector is a class that implements the list interface, and like ArrayList, it maintains insertion order, allow duplicates elements, and it supports index-based access, and it grows dynamically. Okay, so the biggest difference between ArrayList and the vector is that vector is synchronized. Okay, synchronized, making it thread safe. Okay, what is synchronized we will see. Okay, so let's look at some features of vector. Okay, so it preserves insertion order, it maintains the insertion order, it allows duplicate element and null values inside vector, and it supports indexing as well as it grows dynamically. So dynamic size means automatically it resizes when needed, and is thread safe because its methods are synchronized. Okay, so let's look at the internal working of the vector. So we will look at the internal working of vector. Okay, so how it works internally. Okay, so internally vector uses dynamic array. What does it mean? Dynamic array means, so just like ArrayList, when the internal array becomes full, vector creates one large array. Okay, so let's say we have one current array. Okay, and if it becomes full, how it will behave? It will create one larger array. Okay, why it is creating larger array? Because current array is full, and if more elements needs to be inserted, where it will insert? That's why it is creating one larger array, and it will copy the existing elements from the existing array to this new array. So copies element to the new larger array and will add new elements in the larger array. That's how it works internally. So the resizing is happening automatically. We don't need to do anything. Okay, so when the internal array becomes full, vector creates a larger array and copies the existing element into it, and then stores the new element. Okay, so these things are happening automatically. So this is the internal working of vector. Okay, now we heard one more terminology in vector, that is synchronization. What does it mean? Synchronization. So it is one of the what we can say, one of the most important feature of vector is synchronization. So let's say when multiple threads, okay, let's say we have multiple threads, let's say we have thread 1 and we have another thread 2. Okay, so when multiple threads try to access the same vector object, let's say we have one vector object. Okay, this is what vector object. So when multiple threads try to access same vector object simultaneously, okay, so only one thread is allowed to execute a synchronized method at a time. Okay, that means at a time only one thread can work. Synchronized means what? It will there will be inter-thread communication. Okay, inter-thread communication. That means if one thread is utilizing, another thread will pause. And once thread 1, suppose thread 1 is utilizing, so thread 1 will tell to thread 2, okay, I have done my job, now you can utilize this vector object. So now thread 2 will come into picture and will utilize vector object. So that's how there will be some inter-thread communication. So that's what synchronization is. So this both thread will be in the sync to use vector object simultaneously. Okay, so what it will do, this prevents data inconsistency and makes vector thread safe. So with the help of synchronization, vector achieves thread safe. Okay, we will learn synchronization in detail, okay, when we will study in multi-threading. So let's move. So there is a comparison between ArrayList and Vector. Okay, so Vector and ArrayList are very similar because both use dynamic array internally. Okay, we have just seen. So both ArrayList, okay, ArrayList and Vector uses dynamic array. ArrayList is not synchronized. Okay, ArrayList is not synchronized, whereas Vector is synchronized, that is thread safe. So vector is thread safe and ArrayList is not thread safe. And since ArrayList is not thread safe, thereby it will be faster in performance. And since vector is thread safe, why slower? It will be slower in performance. Why I am saying like performance is slower if it is thread safe? Because if it is thread safe, then there will be some communication, right? Internal thread communication will be there. Multiple threads will be synced with each other. So it will cause slower in performance. Okay. Whereas if there is no thread safe, like in ArrayList, so there will be no thread communication. That means faster in performance. Okay. So vector is synchronized, which makes it thread safe, but introduces additional overhead, making it slightly slower. So these are the comparison between the ArrayList and the vector. Okay. So there are some common methods. Okay. So vector provide all the common methods. So these are the common methods. Okay. So vector provide all the common methods available in the list interface, since vector is the implementation class of the list interface. Okay. But it also includes some legacy methods. Okay. Legacy methods such as first element, last element, element at. Because in modern Java applications, the standard list methods are generally preferred. Okay. Now we will see what are the advantages of vector. So vector offers several advantages. Okay. So it will automatically resize. It will maintain insertion order. It allows duplicate elements, and it provides thread safety. Why? Because vector is synchronized. It follows synchronized. So making it suitable for the application where multiple threads access the same collection. That's why it is mentioned reliable in multi-threaded applications. Okay, so these are the advantages. Let's look at some of the limitation. So vector also has some limitation. So because every method is synchronized, additional processing will be there. So this will cause some kind of overhead. Okay, that's why it is somewhat slower than ArrayList. Okay, and it is rarely used in modern applications nowadays. Okay, so vector is used but very less frequent in modern Java development. Okay, when should you use vector? So choose vector when multiple threads needs to access the same collection and thread safety is important. Okay, in such scenarios we should use vector. So for single threaded application, ArrayList is generally the better choice. Okay, why single threaded applications ArrayList is the better choice? Because there will be no thread communication, no thread safety is required, so it will give us better performance. Okay, and if multiple threads are there in the same collection and thread safety is required, in that case we should go for vector. Okay, so vector is useful in applications. Okay, what type of applications? Where multiple threads work with the same collections, such as multi-threaded logging. Okay, employee list, shared employee list, shared task list. So if you are by word only we can analyze. Okay, shared means multiple threads will work on the same employee list. Multiple thread will work on same task list. Multi-threaded logging, background processing. So these are the use cases of vector. So these are the real world examples where vector is used. Okay, so in the hierarchy, this is this is the collection framework hierarchy. So vector, we are reading about vector, and vector is a what? Vector is a implementation class of the list interface. So by default, whatever properties available in the list interface, those will be available as part of the vector implementation class. And see here, it is inherently thread safe. That means with the help of synchronization, vector is providing inherently thread safe and thereby somewhat slower in performance. Okay, so we should use vector where we need multi-threading, concurrency. Okay, so in such use cases we should go for vector. Okay, so let's quickly summarize what we have learned so far. So it implements the list interface, implementation class of the list interface. It uses a dynamic array internally, we have seen, and it maintains the insertion order, and it allows duplicate elements as well as null values. And the most important part of the vector, that it is synchronized and it provides thread safety. That means thread safety means some extra processing. Okay, so thereby it will give in slower in performance. Okay, slower in performance. And ArrayList, since ArrayList is thread unsafe, that's why it is faster in performance. So we can say vector is slower than ArrayList, slower in performance. Okay, so that's all for this video. I hope this tutorial helped you to understand the concept of vector in Java. Thanks for watching, and I will see you in the next video.